The quadratic formula is a formula that gives the solution to any equation of the form ax squared plus bx plus c equals 0. At step 4 earlier, when we did the completing the square, we were at the point that we have the square on the left-hand side and the sum of the two constants on the right-hand side. If we do the taking square root method, we will have x plus b over 2a equals plus minus the square root of the simplified term after we add those two numbers together. With this way, use the property of the root as square root of b squared minus 4ac on the top divided by square root of 4a squared, or square root 4 multiplied by square root of a squared, that give us 2 times a as the denominator of this step. Then we subtract both sides by b over 2a to obtain the finished formula for the x, or it's called the quadratic formula, in the form of x equals negative b plus minus square root of b squared minus 4ac divided by 2a. The value b squared minus 4ac is the radicand under the square root. By restriction of the square root, it has to be non-negative number to come up with the real solution. So that b squared minus 4ac expression is called the discriminant, which determines what type of the root that you're going to get for your equation. If the discriminant b squared minus 4ac greater than 0 or positive, we will gain two distinct real solutions. If the b squared minus 4ac or the discriminant equals 0, square root of 0 is 0. So then we get one real root, or it's called the double root. And the last case, if the discriminant b squared minus 4ac less than 0 or the negative number, we will obtain the complex number, because square root of negative, like square root of negative a is I times square root a, which is the complex number. And since you have plus and minus sign, it's going to be two opposite sides of the complex, which is the complex conjugates. Let's take a look at the examples. These examples, we are going to use the quadratic formula to solve the given quadratic equations. Part A, y squared plus 12y plus 20 equals 0. This is in the form of a y squared plus b times y plus c equals 0. Therefore, the a is 1, b is 12, and c is 20. Use the quadratic formula for the variable y, which is negative b plus minus square root of b squared minus 4 times a times c, and all divided by 2 times a. Substitute the values from the list that we have above. Negative, the b value is 12, plus minus square root of b squared, which is 12 squared, minus 4 times a, which is 1, the c is 2, and all divided by 2 times a, which is 2 multiplied by 1. Then we will get the simplified form of the numerator as negative 12 plus minus square root of 144 minus 8 minus 80, sorry, so since c is 20, minus 80, all divided by 2, and negative 144 minus 80 is the value 64 in the square root that give us the value 8. That means the numerator now is negative 12 plus minus the value 8 divided by 2 as the solution for the y. So we break it up into two cases as y equals negative 12 plus 8 all divided by 2. And the second solution, y equals negative 12 minus 8 all divided by 2 and simplify the numbers completely. Negative 12 plus 8, that is negative 4 divided by 2, turns out to be negative 2 as the first solution. For the second one, the numerator is negative 20 divided by 2, simplified to be negative 10 as a second solution. Another example of the use of the quadratic formula, we are going to rewrite the equation in the form that we can identify a, b, and c as a form of ax squared plus bx plus c equals 0. So we're going to subtract 1 both sides to write in that form. 8x squared minus 4x minus 1 equals 0. That gives us a equals the value 8, b is negative 4, and c is negative 1. Using the quadratic formula, which is x equals negative b plus minus square root of b squared minus 4 times a times c, all divided by 2 times a. Negative b, which is negative of negative 4, plus minus square root of b squared, or negative 4 quantity squared, minus 4 times a, which is 8, and c is negative 1. And all divided by 2 times a, which is 2 times 8. Simplify the numbers completely. Negative 4 becomes positive 4, plus minus square root negative 4 squared, that is 16. Negative 4 times 8 times negative 1 becomes positive 32. All divided by 2 times 8, it is 16. And then for the radicand, that is the square root of 48. Simplify 48 as 16 times 3. That means we have square root of 16 times square root 3, or 4 times square root 3 as the simplified form of this radical. And then we write it as 4 plus minus 4 times square root 3, all divided by 16. And then we can rewrite it as 4 over 16 plus minus 4 square root 3 divided by 16, or 1 over 4 plus minus square root 3 over 4, which leads to two solutions as x equals 1 over 4 plus square root 3 over 4. The other solution is x is 1 over 4 minus square root 3 over 4. Another example of the use of the quadratic formula to solve quadratic equation. This part, we have t squared plus 7t plus 13 equals t. We're gonna start with rewriting the equation in the form of a times t squared plus b times t plus c equals 0, or move all the terms and leave the other side to be 0. So subtract t both sides of the equation to get t squared plus 6t plus 13 equals 0. That means our a is 1, the b is 6, and the c is 13. Using the quadratic formula, solving for the t or for the unknown, negative b plus minus square root of b squared minus 4ac, all divided by 2 times a. So negative b, which is negative 6, plus minus square root of b squared, or 6 squared, minus 4 times a, which is 1, and c is 13, all divided by 2 times a, which is 2 times 1. Simplify the numerator to be negative 6 plus minus square root of 36 minus 52, all divided by 2. In the radical, 36 minus 52, that is square root of 16 with the negative inside. That is I of square root 16, which is I times 4 or 4I. So with this case, we have the complex conjugate involved. Now we have negative 6 plus minus the 4I or I times 4 all divided by 2, or negative 6 plus I times 4 divided by 2, and the other one is negative 6 minus I times 4 divided by 2. And then simplify completely, get t equals negative 3 plus 2I as one solution. The other is negative 3 minus 2I as the complex conjugate solutions. You see this is the same as negative 6 over 2 plus I times 4 over 2. This is negative 6 over 2 minus I times 4 over 2. And then simplify further to get this form of the solutions.